Now it says prove the identity. You're given the left-hand side, it must be proven that is equal to the right-hand side. So question similar to this one, obviously we need to choose one side that we are going to use to prove that it is equals to the other side. In these questions, or questions similar to this one, you need to make sure that you always take the more complicated side. Simplify it and make it looks like the less complicated side. So as you can see in our case here, this is our more complicated side. Therefore, I am going to say left-hand side is equals to minus 2 sine squared x plus cos of x plus 1. The whole thing is divided by 1 minus cos 540 minus x. All right. So now here, this part, I can actually rearrange it in this way. I can rearrange this together with that. But I'll start with the 1. So still the same thing, you'll see at the end. So I have 1 minus 2 sine squared x plus cos x. If you pay attention, this expression and that is exactly the same. The only difference is that I rearranged the numbers, but they're still exactly the same numbers and with the same signs. Okay, so now divide this by 1 minus. Now I have a cos 540 minus x. Let us go back to our cast diagram. So 540 is at this point. So if you count from 0 degrees, you're going to have 90, 180, 270, 360. If you continue adding 90, you're going to have 540. So this is supposed to be 450, and 540 here. So this simply means that at this quadrant, we have 540 minus theta, 540 plus theta. Our expression here, we have 540 minus x. So it means that we're actually on the second quadrant. Now, because it's cos is negative on the second quadrant. So therefore, we're going to have minus cos x. And then this is the same as... Now, the numerator, if you remember from your trig identities or your double identities rather, cos 2x. Cos 2x is the same as cos squared x minus sine squared x, or is the same as 2 cos squared x minus 1, or 1 minus 2 cos squared x. So now if you check at this point, this part here is actually the same as this part. So I'm going to swap this, not with cos 2x, no, I'm going to swap it with that, because this and that has to be equal. So I will now have, I'll use a different color to see so that you can see what I did here. I'll use 2 cos squared x minus 1. That's what I've brought into this expression, plus cos x, and then the whole thing is divided by 1 plus cos x, because negative and the negative gives us a positive. All right. And then now I can rearrange this to be 2 cos, in fact, let me write it here, 2 cos squared x plus cos x minus 1 all over. I'll rearrange this as well and start with cos x. So I have cos x plus 1. Right, so now I'll factorize this. So I have 2 cos x, I have another bracket there. And then here, this is going to be the same as 1 and 1, or this is going to be cos x. And then this is going to be minus, and this is going to be plus. So this is a basic foiling. If you don't remember this, I would advise you to go back to your grade 9 mathematics, or rather you can just leave a comment that you don't understand how this part was worked out, and then I can create a separate video for you guys who don't understand. All right, so this is what we have. Now the denominator with cos x plus 1. Let me put it in brackets. So now here, this part is going to cancel with that part. And then at the end, we're left with 2 cos of x minus 1, which is equal to the right-hand side. This is what we started with. That's what we started with. So moving on to the third question, 5.3.